The dim constellation of Chamaeleon is a true master of disguise, hiding in the darkest part of the southern starry sky. An eternal hunt plays out on celestial maps. This cosmic predator endlessly stalks the neighboring constellation Musca. But its main secret is hidden from sight: giant dark clouds of icy gas and dust. In these gloomy cosmic nurseries, hundreds of new, yet unlit stars are being born right now.
Welcome. Today, we're going to turn our attention to the southern celestial hemisphere, specifically to a region that, well, at first glance, seems pretty unremarkable. I'm talking about the constellation Chamaeleon. It has no brilliant stars, no pattern that just jumps out at you. It is, by all accounts, modest, but this apparent emptiness is incredibly deceptive. It's actually concealing one of the most important laboratories for modern astrophysics. You know, this description is just perfect. Chamaeleon doesn't give you that immediate spectacle. Its scientific treasures aren't for the casual observer. No, they're for the dedicated researcher. It really demands patience, but it rewards that patience with some of the most profound insights we have into the fundamental processes of the cosmos. And right there, that brings us to the central paradox we're going to investigate today. Why on earth does this faint, obscure constellation command the attention of our most advanced instruments? The answer isn't in what we can see with our eyes, but in what is revealed through the lenses of astrophysics. So to really deconstruct this paradox properly, we're going to follow a very structured analysis, the roadmap you see right here. We'll start with the paradox itself. Then we'll map the territory with astronomy and uncover its secrets through astrophysics. After that, we'll explore its surprisingly modern history before we wrap up with some practical guidance for any of you who are keen observers. Okay, let's get into it. Before we can understand what Chamaeleon is, we first have to establish where it is and its physical scale up there on the celestial sphere. Astrometry gives us that essential framework. So the data immediately reinforces this theme of modesty. Chamaeleon takes up just over 131 square degrees of the sky. To put that in perspective, this places it 79th in size out of all 88 modern constellations. It's confirmed as one of the smallest defined regions in the heavens. Now here's what's really interesting. This slide really defines Chamaeleon's exclusive nature. I mean, it is a constellation of the deep south. If you find yourself anywhere north of 15 degrees latitude, and that's all of Europe, most of North America, and northern Asia, it stays perpetually below your horizon. You just can't see it. Only when you get into the southern hemisphere does it become a permanent fixture of the night sky. And this illustrates its role for southern observers perfectly. South of 30 degrees latitude, it achieves what we call circumpolar status. Just imagine setting up a camera for a long exposure. What you would see are the stars of Chamaeleon tracing these perfect, unbroken circles around the south celestial pole, a constant, silent dance in the sky that never, ever ends. All right, so having established its physical place in the sky, we now need to shift from visible geometry to invisible physics. And this is where the true scientific value of Chamaeleon is revealed. It's a realm not of bright stars, but of profound, revealing darkness. Even its brightest stars are faint. Alpha Chamaeleontis, a pretty standard white main sequence star, is barely visible to the naked eye. What's more intriguing, especially for the amateur observer, is Delta Chamaeleontis. It's a visual double star, and through a simple pair of binoculars, its two components resolve into this beautiful contrast of orange and blue light, a subtle, lovely detail in an otherwise sparse field. But here is the real treasure, the Chamaeleon molecular cloud complex. These are not objects of light. They are vast, cold, dense veils of gas and dust that stretch across space. At a distance of 400 to 600 light-years, they're one of the closest active star-forming regions to our own solar system. They are, in effect, cosmic incubators. And this is the crucial point. Inside these dark clouds, hundreds of stellar embryos are taking shape. We call these T-Tauri stars. They're basically protostars that have ignited but haven't yet stabilized into proper stars. Studying them is like observing our own sun's formation 4.6 billion years ago. It gives us critical clues as to how planetary systems, and maybe even life-bearing ones, come together from the dust. And in this really striking display of cosmic symmetry, Chamaeleon shows us not only birth, but also death. Within its boundaries lies NGC 3195. This planetary nebula is the ejected outer layers of a dying star. Through a telescope, it appears as this faint, ghostly disk, a celestial smoke ring, you might say. a poignant epilogue to a star's life, happening in the very same region where new lives are just beginning. Let's now shift our perspective from the cosmos to human history. You see, Chamaeleon isn't some ancient constellation from Greek or Babylonian lore. No, it's a modern invention, born from an era of unprecedented global exploration. Its story really begins in the late 16th century. Dutch navigators, who were charting new sea routes to the Spice Islands, were the first Europeans to systematically map the far southern sky. They're the ones who recorded these faint stars. The cartographer Petrus Plancius then gave it the form of a chameleon, an animal that had fascinated those very same sailors in Indonesia. And finally, it was cemented in astronomical history by Johann Bayer's definitive 1603 star atlas. Now, because it lacks any classical mythology, Chamaeleon's story wasn't written by ancient poets. It was written by its placement on the celestial sphere, and this position gave rise to a unique, modern narrative, a little drama of predator and prey written in the stars. The stage is set by its celestial neighbors. You see, as cartographers were filling in these new skies, they didn't just plot stars, they told stories. They saw the constellation Musca, the fly, positioned directly in front of the chameleon. And this proximity was just too perfect to ignore, creating this vivid and inescapable little drama. The plot is simple, but it's really effective. The chameleon is perpetually stalking the fly, its form oriented as if it's about to strike with its tongue. This little celestial drama is a perfect metaphor for the new and exotic world those 16th century explorers were discovering, a world of strange creatures and dynamic ecosystems, now immortalized in the sky. So let's conclude by translating all this academic knowledge into practical application. How does one actually observe this hidden treasure? Well, it requires some technique and, frankly, the right expectations. First, you have to locate it, nestled in a dark patch of sky between the brilliant star Canopus and the pole. To the naked eye, it's pretty much a void. But with simple 10 by 50 binoculars, a faint rhombus of stars will emerge. For the dedicated astrophotographer, however, Chamaeleon offers a supreme challenge and reward. It's only through long exposures that the dark clouds surrender their secrets, revealing these faint, painterly strokes of brown and gold against the blackness. And so we return to our central theme. Chamaeleon is the ultimate symbol of hidden potential. It doesn't boast about its importance with bright lights. Instead, it quietly performs one of the most vital functions in the entire cosmos. It builds the future. Within its dark, unassuming clouds, thousands of new suns are being forged. And that leaves us with a final thought. What other profound secrets does the universe hide in plain sight, just waiting patiently for us to look a little bit closer?
Thank you, friends. Strive for understanding and become wiser. See you soon.